Good evening, everyone. I'm AJ, and today I'm going to attempt to convert this mask to a respirator. I already disassembled it. So the reason why I'm trying to do this is because I live on a small island where we don't have any any other occupation except snorkeling and diving for tourists, and we have hundreds of those masks currently on the island, and nobody is using them. And our hospitals are struggling without protection. So my idea was to design and print some kind of a connection here that I can use as a filter. And I already asked my friends to help me, my doctor friends, and they send me some information regarding the materials they have. And yeah, that's what I'm going to do. This mask is technically almost same like biohazard protection. It's a fully airtight respirator. The rubber part and the plastic part is the design is same like a fully airtight respirator. The only difference is that it doesn't filter the air when it enters. So I will show you what I found so far, and there are quite a few existing designs. So this one was the first one I found, and it looks like it will fit my mask. See that this part, yeah, like that, will fit. But the big problem in such designs is that the surface of the possible filter is too small. And if there will be any kind of resistance in this area, the doctor who will wear this will have problems breathing. And this can actually be a serious barotrauma because the lungs will be always inhaling the air slower than they are supposed to, and a little bit of blood will always come inside the lungs, and that will accumulate. And at some point, this can cause death uh, if you are not aware of that. And the surface must be much bigger. The bigger the surface, the least the resistance we have, and the least amount of the more hours we can spend in that mask. Another design I found is this one, and this one is actually used for lung ventilation, I think. So I don't think we can use it, but at least I can get some measurements from it. And the reason why I don't, I already have some designs that I printed. Let me show you closer. So I printed some ventilator valves for this mask, and they turn out not that well. The prints are, I'm not sure how to properly position them. I tried two different orientations, and both of them didn't work super well. And it has a lot of support inside. You can see that. Okay, so it's full of support inside, and it's really hard to remove because there are some channels, separate channels, air channels. Yeah. And my friend told me, he's a diver, and he told me that these pipes are sometimes different. So they are almost same, but there can be variation. That's why we need to design our own model so we can adjust the size if we need. Okay, and here we have a guy who.
Hi, my name's Randy.
One second, yeah, this one. This guy posted a video, and he just taped. He just used electrical tape to mount a respirator filter on top of the mask, and it was. I think he says that it has too much resistance. So in his next video, he applied two filters, and this was better for breathing. It's easier to breathe with two filters because there's much more surface, filtering surface. Another design I found is this one. So this one is actually ready to print. The blue model is the one that is going to be printed by multiple layers of plastic, melted plastic in my 3D printer. But it's not clear what is included in this design, and usually on this website they have STL files. STL files, they are ready to print, but they are not ready to be adjusted. So if you really want to change the size, you can only scale it, but you can't adjust the measurement. Another design I found is this one. By the way, if you can hear the microphone, if you can hear my voice, just tell me yes in chat, so I'm sure that you can hear. And is anything okay? Is everything okay with the video? Because it's my first time going live in YouTube, and that's my first YouTube video. So this is close to the design I want to make, but while it's perfect for single person use, I don't think this will be very convenient for doctors to cut out circles like that. I mean, it's still fast, but I think it will be much more usable if the filter will be square. But having a square filter uh, removes the option to use the thread. So here he uses a thread, a huge thread, um, to apply the cover on top of the filter, but I still need to decide if I will go the round or rectangular shape, and just let me know in the chat what are your thoughts. So this one goes rectangular, this one is circle. We will do something, one of those designs. Yeah. I have a couple of videos here where people attempt to do that. So I'm not the first. We're not the first who have this idea. And the reason why I'm doing this is only because we have a really, really big pile of those masks. And some people are attempting to print respirators, and it takes time and it takes some filament to print them. So why not use things that we already have? And they have a really good airtight. This rubber seal is if I will wear this, I can't breathe. If I close the hole, I can't breathe in. So those are already high grade protection, and depending on what filter you put inside, you can get different kind of protection. So if we put a N95 filter, we can get an N95 protection because there is no air going inside. It's a fully sealed mask. So the in a normal mask, you have some air or some gaps on the side, and that's why it's N95. It can't stop air going from the side. But this one can be N100, I think. I'm not sure about those measurements and how to test if it will be N100 or N99. But anyway, if I was a doctor and I had a choice, I would prefer this one instead of wearing separate glasses and a separate mask. The only downside of this mask is that it's really hard to wear with glasses, but I will ask my friends if maybe they have some pads or something. Maybe divers have a solution for these kind of masks, or maybe people can use contact lens. Yeah, so this is the guy here. Most of the guys are doing duct tape and some glue, and what I'm just going to do is I'm going to design and print this semi-professionally, so people can easily use this in on my island. And we have a couple of printers on the island, so I think we can do maybe 50 or 100 of those and pass this to our hospitals. So what I will do first is I will download these two designs and I will inspect them. I will check their sizes, and we will see if we can use them. Because what I do usually, if I don't have any designs online, I I would take a picture of this one, and then I will upload it to my software and trace the size and calibrate the size. So then I will extrude and I will have this shape that I can use in my design. But because printers they usually have plus minus half millimeter difference, it's always a nice idea to have something already pre-made and create everything from scratch. But we will print a calibration ring anyway. So at first I will design only a plastic ring, so we don't lose time designing a huge thing and then print it, spend like 5-6 hours printing to find out that it doesn't fit. So yeah, let's do that. And this is going to take maybe a couple of hours, maybe longer. So I will just turn on some music, and because it's YouTube, I'm not allowed to use normal music, and I will use some royalty-free music. Hopefully, it's not going to be very terrible. But this Spotify playlist is specifically designed for live stream. Okay, so I will start with that square design. This looks interesting, but the mask looks a little bit different from what I have. Let's download the file, and we can tip the designer. Oh, sorry, I forgot to put on my screen. Yeah, okay. Downloading the file. The internet is not that good in Philippines these days because everyone is using the connection. But after midnight, which is going to be soon, it will improve. No, I made a typo. And I will download this one as well. Okay, let's open that folder. and I will extract both of them in separate folders. So in here we have a printable file. It's called STL, and STL files, they are made of triangles. I don't know why, but they are. And once a model is converted to this format, it cannot be converted back. This is how it looks like. Okay, so and it looks like it has a mount for some kind of existing filter probably. So this will not work for us because what I got from our doctors is this. I'll show you. So they have this material that they use for covering the tools, and it's sterile material. It's N99, and it can still be breathable. I don't know how to say that. So what we need is some kind of a pillow inside the filter, and we need to cover it both sides with different grade material depending on what side what we want to filter the air. But they already said that they will store as much as they will find as much as possible of those materials. So basically they can cut any shape and any number of layers, and this is how they will adjust the resistance and the protection. Okay, we'll close this. And let's check the second file. Mhm. Okay, it has 4 parts. Those are quite complicated designs because they load such a long time. Okay, so maybe we can use this as is, and this one looks like it's going to fit. And then the other part is circle. Maybe I can redraw the circle part to make it square. Let's see. Okay, the second file it looks like this. That's the lead. Take some time to open those files. Okay, so we have this is a base of the filter, I think. The guide and the body. Okay, those look. This is the body. Yeah. Yeah, this is something we can work with, and I think this one looks very similar to what I have. So I'm going to import this to my Fusion 360. It's a CAD software that I use, and we're going to see if it has right dimensions. Okay, I already created a project here. Where was that? Okay, one moment. Respirator here. Trying to keep this organized because this I will upload it online so everyone can print this, and I will upload the file that we just downloaded. Where's this one? And we will take the link. Okay, upload. So Fusion 360 is a CAD software that is fully 100% cloud. So whatever I do is stored somewhere on their servers. That's why it may take some time to open things and to load them, but at least it's safe. If I will have a power out or something, my files will be safe. Okay, so we have it here, and let's try to take a measurement. We will inspect and we will try to measure the distance between these two. So okay, it's 191 millimeters. So that's 19 centimeters. It doesn't sound right. Yeah, and this happens with STL files. Oh damn, I have low battery in my caliper. Okay. Luckily I have another caliper. I should have. Let's see. So I see that this one is around 19 millimeters. So probably the model is scaled 10 times. Let's try to scale it when we import. I will import the model again. And here I can, no, I can't scale. Okay, let's scale it later. Okay, let's see if we can scale. Okay, so we can scale STL models, but I will convert it to a solid object first, and to do that I need to disable the history, and I will create a new body from mesh. Okay, now it's a body, and I can enable the history back. And now I'm supposed to be able to scale it. Okay, let's try this body. And let's scale it 0.1. Okay. Okay. Now let's measure again. No, we need the dot to dot. Okay, let's scale. Let's scale this dot. This one. Yes, 19 centimeters. And I will not try to make it perfect now because the printer will add some error. So it's much easier to just print whatever it is and see how it will work. I will create two planes and I will cut a piece out, maybe just, let's take 6 millimeters, and I will split that body with two planes. Okay. I had an error, and let's see, maybe we need to split with one first. Let's try one. Okay, no, it doesn't. Okay, this happens because the plane is going through. I need to move it a little bit, so go back and let's just move it 1 millimeter that way, and we will create another one that will go 6 millimeters the same way. And now we will try again. Can we please? And it's thinking better than error. sometimes Fusion takes time to think, and sometimes it actually hangs. This happens, so I have to remember to save my file. Okay, it gives me an error again. Okay, I will save my file and I will try to split it one by one without extension. It can also fail because of those high detailed shapes. And if this will not work, it's still okay. We can just project the inner shape, and I can draw a new sketch from scratch. Maybe this is going to be even faster. Yeah, because it doesn't work, maybe I will have to. Okay, so I know that's the mesh of the bodies, and some holes are not making it solid. So this is technically not a solid object yet. It's just a bunch of walls with air inside, and that's why the problem happens. Okay, so let's try to create a new sketch in this orientation, and I will project. Wow, that's okay. I'm going to project the whole body. This is going to be a mess. And then I'm going to project this part, because I only need the sizes, and I could enter them manually, but let's capture them from here, print one piece, and then measure the error, apply a fix, and then we can design the whole thing. I'm just taking the whole wall. Okay. This is the projection. Basically, I can already use this. And what my concern is that while the design uses flat walls, the actual mask they are not that flat. It actually has a little curve on top, and I'm not sure how essential it is to keep that. And let's see the other part. Where's the? Yeah, here. Okay, so the second part also has that slight curve. Okay. Maybe I should take a picture of it. Okay. I will take a picture of the thing and send it to my Fusion. But I need to make sure I make it in the straight projection, so there's no errors due to camera and I will take this also. Take a picture of this. Okay. I'm going to send those files to my messenger. It's the easiest way to get those in my PC. Okay, we don't need this complicated model anymore because I'm going to design a new one. So I will hide it for now. Let me try one more split. While I'm downloading the file, yeah, another error. Okay, trying to get at the moment where I scaled that, yeah, and then hide it. Okay, good. Now I need to insert a canvas, and I will do it into the canvas from my computer. I will insert this one. And yeah, I'm going to paste it here like this. I'll turn it 90 degrees this direction. Okay, and yeah, it needs a little bit more rotation. Let's make it straight like that. Mhm. Okay, this looks straight. Now we need to calibrate that. So I will mark 2 points that I know the distance. Yeah, okay, from the distance from this point to this point, I will measure it. Okay, it's around 15.5 millimeters. Let me check again with another caliper. Okay, 15.7. Good. Okay, now we start a new sketch. And this one is going to be, because of those arches, those curves, it's going to be not as simple as I was expecting, but it's still okay. Okay, let's do like that. I will draw the outer side of this thing first. Okay. What do we have here? 17.4 millimeters radius. So I suspect when they were designing it, it was 17. Okay. We create another circle and we make them equal. We make them constrained to same line, and we will make them symmetric uh, with this line as the center. One, two, line. Yeah, so now I can my canvas is not centered very well, but I will fix it. Okay, and I want to make them on the same line with the center, like that. Move the canvas a little bit. Okay. Now we will create two lines with the curve outside. And I will need to make those curves same. And also their angle. Okay. Yeah, that's what I need. Now I want to make them also symmetric. They start at the same point. Okay. Let's check this point, and this line. Okay. And let's fix the distance between those centers here and here. 27, I guess, was the idea, or maybe 26. I think 26. No. Sorry. Okay, let's do it 27. We will print one and we will see if there's a gap. I will just add 1 millimeter. Make a line here. Looks like this one is a straight one, and I will make a tangent to those circles. Okay, and I will try to make this one. Should it be tangent also as well? Yeah, okay. Nice. That looks like what I need. Okay. It's a little bit challenging, but it's fun. Okay. Nice. And we will fix the distance between these points so they don't move. 31.3. Okay, let's try 32. No. Okay, let's try 31. Okay. 31.5. Yeah. Let's try that. Now let me try to move the canvas again to make it perfect. And remember that the camera is not always perfect, doesn't take always perfect pictures. When we are dealing here with half millimeters, so there could be some error. Okay, here, and yeah, we're seeing quite a big error. Okay. I will move so that the error is distributed equally on left and right side, and I will just change this distance to 26. Let's see. Better. Okay, 26.5. Yeah, that looks perfect. And now we need to adjust this again. 32.5. Yeah. Okay. So this will be the neck of the mask that I will design around that. This is just for convenience for me, so I can test the sizes right in my software first. Okay, so the first body will be created as a separate component, and this will be the mask neck. Now I'm going to create a new object, and I'm going to call it filter. I don't know, let's call it filter. And I will start with taking a projection of the mask neck, and I will take offset. Let's start with 0.5 millimeter. Maybe even 1 millimeter offset. Okay, no, let's do half millimeter. Yeah. And we will add a second offset for the wall. This will be also adjustable depending on the thickness we need. And we can only experiment to figure out the best one, but this one looks like 2 millimeters is going to be quite strong. So this will be the body of the filter beginning. Okay, so now we have two bodies, and one is supposed to be sliding on top of each other one. Okay, so now regarding this thing, let me show you. This clip is designed to be easily removed from the mask, so you can store it like that, and you save space in your bag, because this is designed for travelers, for backpackers maybe, for tourists, I don't know. So this is designed as a portable device that you can bring with you and even bring it to another country with you. So the idea of this clip is to make this portable, but since we're using it for life protection, we don't need portability, and we will use duct tape anyway to seal any air. We will put some tape around here, I don't know, medical tape or any kind of tape. So this will not be needed actually, I think. And if we really need it, we can add it later. But for now, for calibration purposes, we will not add it. And I will print a 4 millimeter piece right now, so we can check if the curve is correct and if the size is correct. Let me know in the comments if the music is it not very loud? Is it okay? Is everything okay? I will close these parts because we don't need them anymore. Okay. Let's check our STL file. Oh, sorry. I sometimes I forget to switch to my screen. Okay, let's flip it. And we will print it in 0.4. That's the fastest. Let's see how long will it take. Okay, 4 minutes. That's fast. Okay, let me check if my printer is on and we can start the print. Okay, I will go check my printer and I'll be right back. Yeah, it looks like it's going to. It looks like it's on, and I'm trying to reach it with Octoprint. Sometimes it changes the IP address and it's hard to find. Let's increase the quality a little bit because 4 minutes is nothing, and let's just make it more accurate. Unable to slice. Okay, let's try again. Okay, 7 minutes. The printer is offline. Trying to connect to my printer, and sometimes it doesn't find itself. We need to connect. Okay, 0.15. Let's see. Yeah, this is my Octoprint. Let's see if we can get the signal from the camera. So here I have two printers here, and Alfresco is my CNC machine actually, but they can both print with the same settings because they technically have the same electric side. They have same motors, same motherboard, so there's no difference in code. Yeah, so I'm now live, and I will try to home the head. It's you don't need to do it. It will do it automatically when I start the print, but I just want to make sure that the camera is not obscuring the printable surface. And the software will generate a time lapse. Yeah. So now it's supposed to be ready to print. Are we? Yeah, we are. So now it's going to hit the bed first and then hit the nozzle and start printing. And around in 7 minutes, we will have a calibration ring that we can use to see if we get the right size and the right curve. I will call it calibration ring. And I will hide it. I'll make a new one. Let's make it 40, 42 for now. This software is nice because we can change all the dimensions later, and I can make it parametric in future. Okay, now I can hear how printer is turning on its ventilator to hit the nozzle. The bed is already at the target 60 degrees. Okay, and the nozzle will hit up to 200 degrees, and now I have a temperature error. Okay, yeah, sometimes this happens. I have some wires are sometimes have a bad connection. I will try to fix that. That will be embarrassing if it will not work today. And the terrible part is that I don't have any delivery service, any parts in my country. We have total lockdown. The airplanes are not flying, so our equivalent of Amazon is closed, and we can't buy any parts. So you can use only what you have, only what you prepared before. I restarted the printer, and we will try again. Okay. I will reduce the temperature slightly because sometimes my printer has trouble going up to 200 degrees. Started recently, still not sure how to fix that, but it works at 195, even better for you. Okay, the heating doesn't work. This graph is supposed to go up. This means that the hot end is not powered, and I need to figure out which wire is that. So the face of the doctor, I think it will be logical to take the air from behind, not from in front, so they are protected from the patient. Because this mask will be used, I think, only with those patients who are really bad, and the it's better to breathe, take the air from your behind, not from your face. So I I'm thinking I can just make it like a straight pipe here, and then it will get bigger, and we will have a square large filter here, and maybe even double-sided. Still not sure. Let me know in the comments what you think about it. But if the filter will collect the air only from one side, I want to make it the lower side. So because this side is exposed to any sneezes or anything, this will be naturally covered, and I think it will work better in rain. It will not get wet, and the doctor will not suffocate. So yeah, I think it's going to be here, and I can even bend it a little bit, maybe put it like that here. So it's like a cup. I'm not sure if doctors have some, if they wear some hat or something. Okay, the printer is heating. The bed is at target temperature, and the hot end is also at target temperature. Let's see if it's going to move. Yes, it is moving, and I will now adjust the camera so we can see what's happening better. Okay, we have the first layer going on. Now, in order to print this easily, I should maintain one side of the device flat, preferably. And it will be hard to print if I will lay down like this. There will have to be support in the middle, so the top walls can hold, because printers can't print in air, and that's why positioning the device while printing like this will be maybe better. Yeah, let's make another sketch. This time I will make a rectangle, center oriented, and we'll be able to change that. Let's use again 42 and maybe 100 millimeters. Okay, let's make it 21, 22. I will make these two lines collinear. Okay, I can't make it because we already have a constraint that is a central point. I will remove it. Yeah, it's easier to remove the rectangle itself. So I will just draw a random rectangle here, and I will make sure that this line is collinear with this one, and I will make sure that these two lines touch. Okay, I need to project that line to use it. Let's project all of those. And let's try to make it collinear. Okay, so that one, that's not a circle, so it cannot be tangent. We will just manually try to adjust it. First, I will make these two, I will make those symmetric. Okay, we don't have a central point also. Let's project that. We can project that. Okay. Let's move this here. I will create some lines that I can use as a central line. Okay, and we'll make this line center here. Yeah. Now we can make those symmetric. Let's make another line here. Okay. The width. So by adjusting the width, we'll be able to adjust the resistance of the filter. Let's measure the height of the part that goes inside. This one, we'll measure that, and that's 18.6. Okay, let's say 20 millimeters. We will make it 22 to make sure. We have the neck. Oh, okay, so this body goes to the filter, and we will edit that and make it 22 millimeters only. And now I'm going to extrude the filter box, and I'm going to have to set offset to 44 millimeters, which is twice higher than the neck. And I will make it, let's make it, let's make it 14. No, we can, okay. So offset is 44, the distance is 14, one side. Let's try to extrude it again. We will make it okay. Let's hide the body. Maybe that's the one that is obscuring the way. Let's try. And I will hide all the unneeded sketches. Okay, meanwhile the print is done, and I'm going to take this later. We will create, let's try to create down. Okay, it was building. can happen because of those lines. Let's try to remove those. Let's make it slightly. I think this happens because those lines, those two lines are intersecting. We will make it slightly different. We will remove this constraint and make it 24. And let's see if that works. Okay. Yes, so this one is working. Let's make it 100 for now, and with the offset of 48. Yes. Now let's try making a lock. Okay, now we need to first make it hollow. Let's stick to 2mm walls. Okay. And let's apply some, we will round some edges just to make it stronger and easier to trim. Maybe it's too early to add them, but because I want to make a loft, I want to smoothen them before I do that. And you'll see why later. Yeah. Okay, let's make it 4mm. 6. Okay, 5. 5 is better. That's a complicated loft. So now I need to connect those two geometries, and this is a tough task usually. But Fusion 360 sometimes surprises me how it can figure out those things. Let's see if it can. The loft could not be created. Something real. Okay. Yeah, it's too complicated to join those geometries for Fusion. But there are other ways to do, and those are the challenges that an engineer is having when trying to do things fast and when trying to adjust for existing devices. So one thing I want to try is to copy these parts and just make it bigger, and because those profiles are, they will be same shape, hopefully a loft could be created. Let's see if it's possible. Let's scale that. So that's thick. try to align them. Again, let's take the center of the one and align with the center of the second one. Or maybe when I scale it, I should not. Yeah, I should choose a center point to scale it around. We will try this body and the point. I can't select the one. Let's try this one. Looks like that is centered. Okay. Let's move it down. And let's make a loft again. Let's see if Fusion is smart enough to join. No, it can't. Okay, so I can revolve. I can try a chamber. Yeah, I can try to do that. Okay. Let's prepare stuff from this object down 2 millimeters, and we will remove the edges. And now I'm going to combine those bodies so that they are joined. I will put the object. Now this is the same body, and I can apply chamfer like that. Yeah, that's what I want. Okay. Yeah, okay. Let's try 30. No, 30 doesn't work. 29 works for now. And let's inspect what's the distance here. We still have 17 millimeters. That's not enough, so I will extend this 5 millimeters down, because we need 22 millimeters to go. Okay. And we will need to make it somehow convenient to replace the filter, so the filter should be replaceable. I will close this for now. Okay. Nice. Yes, that's what I wanted. And we will make a sketch here. No, not too much. In this area. This is the area we can work with, and we will leave some distance, let's say 6 millimeters. on the side. Everything is possible to change because it's really easy to print. And by the way, the print is ready. I will check it now. Let me take it off. Okay, so this is what I have, and let's see how it works with this mask. That's a very tight fit. So it fits, but it's a really tight fit, and I don't think that I think I need to make it bigger, just maybe half millimeter. I have some sandpaper here. The first layer is a little bit bigger than the others, so I will try to remove the first layer only to test this. So some people are asking me if I'm recording. I think YouTube records this automatically, and I'm recording this as well, so I can edit out some parts later if needed. Okay, so what I will do is I will print another one, just half millimeter bigger, and I will see which one fits better, because it only takes 7 minutes. Okay, so this distance will be 0.75, because 0.25 on each side will give us half millimeter. Yeah, and I will also add 25 there to keep it 2 millimeter wall, the wall. Okay, now when I change that, everything still looks intact, but let's check if we still have the same size of the ring. Yeah, it's still the same size. Nice. That's my dog barking. Okay, so we will print another version of this file, of this body, slightly bigger. Okay, I will name it calibration ring. Okay, let's start another print. Meanwhile, Okay, so this this side became solid, and we don't need that. That's too much plastic, and we need to save plastic. So I will try to apply chamfer inside also. 28 goes well. How about 29? 29 doesn't go. Okay, so if we do 28, and let's see how it looks like in if I cut it. So this will be the thickness of the wall, and I think it's too thick. We need to make it 28.9. No, okay, 28.5. Okay, 28.2 is the highest we can go. It's okay. Oh, by the way, I wanted to make the hole on another side, other side. So yeah. So so the hole will be on the bottom. And they will put the layers of something. So we need to create some kind of mesh on this side to support the filter. Yeah, that will require a lot of support to print. So maybe I can make a cartridge, some kind of a cartridge that will be inserted from here, or maybe even like that, mm, on top of it. Okay, the printer is heated and the print starts again. And will it crush the camera? No, it doesn't. Sometimes, sometimes it touches the camera. Yeah, it does a little bit. Okay, does anyone have any ideas how we should make the filter easy to replace? Some kind of cartridge system or something? We will figure out. We just want to make it easy for doctors so they don't spend too much time doing the job of building those filters and replacing them. Maybe just another box that goes inside and has the holes everywhere. Hmm. In the print. Okay. So I will probably print it upside down like this, so I can place some vertical lines, and those will not require support. Let's create some supporting lines. 22 millimeters. Okay, so we will not do it until the end. We will we will figure out later. Mm, something like that. And since we already have 2 millimeter walls everywhere, we need to make it 2 millimeters. And I'm going to make these parts equal and also symmetric. Okay, this is okay. Let's give them some finite length. Let's make it 110. And we will make them collinear. Oh, not this one. Not this one. This one. Oh, no, that's not what I wanted. Let's say 60. No, 55. Okay, now I'm going to extrude those. Maybe 10 millimeters. This is going to be a lot of plastic, more than I was planning. Yeah, and we will just make a box that goes inside and maybe clicks, or maybe we can screw, or we can make it sliding in. But what's nice to do is also to allow them to use filters of different thickness. I'm actually not sure how thick the filter should be, and maybe that's too much space. Maybe the filter should be much thinner, but I don't want to anything to obscure the airflow. So yeah, let's make those things 16, maybe even 18 millimeters. This distance between these two things is what will be used for the filter. Okay, let's make a box. 2 millimeters walls again. The print is done. No, this will from object from this object I want, and I want 2 millimeters. I want them to be touching. Here's my last sketch. Okay, so doesn't look like it was created somewhere where I think I created in the wrong object, but I can fix that later. Ah, okay, here it is. Let's extrude the wall. We will start from object from the floor of the box, and we will do two objects here, and we will also go a little bit on top. We will go 2 millimeters on top because we want the box, the inner box, to have some kind of a border, a frame, like that. Okay, and we will hide the body, and we will, yeah, that's the box I want. Did it? Is it the same body? No. So separate bodies are created. I will combine them. This will be the filter box. Let's see how the other guy did. I want to see how they did the top part of the filter. So nothing is holding. I was thinking to add some screen. Okay, nice. Let's add the frame. 2 millimeter frame. I will call it filter case. Okay. Now, to make them fit, I need to apply a little bit of clearance between this sketch. I will create a clearance. Say 0.5 millimeters, and this will be 2.5. Yeah. Okay. Looks like that's what I want here. And now we will need to perforate the bottom. And I need to think about how I will print that to make it easy to print. Let's make a slope. Four millimeters, 12 millimeters. The distance from the wall is 4, and also this one. This one. Let's say 4 also. No. Okay. And we will create a rectangular pattern. We will take this shape. We will move it like that. And like that. So actually, if we will change the size of that thing later, it's going to be complicated so it's going to be hard to extrude all of that. So I will first extrude one, make a hole. What's this? This is wrong. Okay, wait for it. This is a single body, and somehow it got this nudge here. We don't want that. Let's edit this feature. Not to include that. Clear. Yeah, now it's right. And now we can create a rectangular pattern. We will pattern the feature in this direction and as well this direction. We already know this is minus 82 and we have 12 pieces. And this, the other direction, will have 4 slots and it's going to be 50. Okay, let's try. Yep, that looks fine. So hopefully this will be this will have less resistance than the other model, and also hopefully easier to manufacture.